It's a pleasure to, restart the semester. Okay, I'm sure all of you are excited, and I think many of you are planning to come back to campus or probably are already here. And I guess it's been like a long wait for, it's been more than a year, I guess, since any kind of interactions happened, like physically. But yeah, this semester also it appears that it's going to be online, so we'll have online classes. So let me just introduce myself first. My name is Divya Padmanabhan. I joined IIT Goa as a faculty member in the previous semester. Okay, so beginning of this year. I did my PhD from Indian Institute of Science, Bangalore. So this was about 3 years back, and my PhD thesis looked at machine learning and game theory, topics at the intersection of these. And after my PhD, I was in Singapore. So the last 3 years I've been in Singapore. I was a postdoc there. And so during my postdoc, I kind of got into this area of robust optimization. Okay, so currently my research interests are in robust optimization, machine learning, and game theory. Okay, and I've also worked in the industry for about 2 years. So this was like long back, after I finished my undergrad and before I started going for my higher studies, I worked in Oracle for 2 years. Okay, so this is just a bit about me, and yeah, in terms of hobbies, I am a singer. So I am quite interested in traditional art forms like Carnatic music. Okay, so a very brief intro about me, and of course, we'll get to know each other a lot more over the span of this course. Okay, so yeah, I think, yeah, I don't see any faces. I've met some of you from your class, like over the summer in terms of the projects, but for a big majority of you, I'm yet to know you. So yeah, I'm really looking forward to this course. Okay, so let me just start by maybe giving a formal overview of what the logistics and all would be like. Okay, so I will share this page with you. So this page is visible, right? This is kind of something I just made to, tell you about the logistics. Is this visible?
Yes,
CS 330.
yes,
Okay,
yes.
cool, cool. Okay, so yeah, one more thing is, since I'm sharing my screen, if you type something into the chat box, it's not visible to me. So please interrupt me if somebody types something, or of course, you're most welcome to then, unmute yourself and ask. Okay, but just stop me in case you see a question on the chat box. Okay, so this is the AI course, and I know all of you are very eager and enthusiastic about it. I'm also very much looking forward to teach you guys this. And so the idea is that you will learn some of. I mean, it's a very vast topic. It's a very broad topic. So there are some topics which I've kind of shortlisted in some sense. And so that to give you a kind of an overall flavor. But the idea is, if you have the basics from this course, maybe you can go and read up later. Okay, so the prerequisites for this course, I think I already dropped you a mail about it, but just for completeness, you should have done one course on probability statistics and also a course on data structures, because those are going to be used like very extensively in this course. Okay, and as you all know, there's a lab component also, and there's going to be a good deal of programming, mainly in Python. Okay, so there's also a potential for doing some programming in R also. So we'll just see that the first part is going to for sure be in Python, and later, depending on how things go on, and in the second half maybe there might be some R coding, but we'll see it at that point. But for now, it's primarily in Python. So start refreshing on this. Okay, so the instructor is myself, and we have a couple of teaching assistants. So Akanksha, Vaishak, and Deeptiman will be assisting me in this course. So I don't know if they're here. Akanksha, are you here?
Yes, ma'am.
Okay, so maybe you can just introduce yourself.
Okay. So I hope I'm visible. Hello everyone, I'm Akanksha Mishra and I'm currently pursuing PhD in Computer Science Department. And I'll be a teaching assistant for this course, so you can ask if you have any doubt.
Yeah, thanks, Akanksha. Is Vaishak here? So
Yes,
Vaishak
ma'am.
and Deeptimar are they are MTech first year students, and they just joined, I guess, in the last week or maybe even just yesterday. I don't know.
Yesterday,
So
ma'am.
just yesterday. Okay,
Yeah,
so
ma'am.
I just dropped a mail to them like yesterday night and asked them to join. So Vaishak, why don't you introduce yourself?
Okay. Hello, guys. I'm Vaishak and I'm from Bangalore. I did my BE in computer science, and my hobbies are playing cricket and watching news.
Yeah, thanks, Vaishak. It's nice to have you here. And is Deeptiman here? Okay, he's just joining in now. Okay, he's from Deeptiman, you're here? Yeah, hi, Deeptiman. Okay, so I'm not able to hear Deeptiman. So maybe, yeah, I think you will get to know him over the course of the whole semester. So we have three teaching assistants, and I'm really glad that they're helping me out with this course. Okay, so the lecture timings are the following. So I guess you all got it from the timetable. So it's Tuesdays 9:30 to 10:20. That's the current slot, and Wednesday 11:30 to 12:20, and Thursday also 11:30 to 12:20. The lab timings will be on Thursday 4 to 6 p.m. Okay, so these are kind of frozen, and I know there were some people, some students from other departments who wanted to do this course. So yeah, I mean, it will not be possible to change these timings, unfortunately, because even it's been like very hard to fix the timetable for all the courses so that there are no clashes even within CS. Okay, so this is yeah. So my advice to some of the students from the other branches who want to attend are: you are most welcome to learn the material and go. I mean, you can be a part of the classroom and attend the lectures at your own will. But first and foremost is your other department subjects. I mean, your own branch subjects. Okay, so at no cost should you compromise those. Okay, but I have no objections to your gaining knowledge from this course, and anything for which needs to be done formally in terms of credit or audit, that would have a policy to be followed. And yeah, so please keep this in mind. Okay, now the resources for this course. So there is a textbook on artificial intelligence, so that's there. But more than that, a very useful reference is this course at Berkeley University. It's the CS 188 course. So I've just opened that page here. Okay, so this is what it looks like. So this is a course which they have been building for since quite some years, and so there's a lot of content here which is like really useful. Okay, so you should definitely go through this content. And so even the videos and slides, everything is available. Okay, I think I have some spam here. Yeah, but these are, so there are these lecture videos and, homeworks, and there are a lot of things which are, would be very useful. And I will be primarily following the flow of this course. But of course, I'll be teaching things in the way I perceive things, so according to, my perspective. Okay, but for, some more details and maybe a slightly different perspective, you are encouraged to go through this material, okay, in the CS 188 page. Okay, so yeah, so that's one thing. And yeah, the textbook, yeah, this is the standard AI textbook, the Russell and Norweg book. So it is a good reference in the sense like all the topics are would be there. um, but just a word of caution, because sometimes there are like maybe too many details at some times, which in my view maybe it's not you know very critical to have a lot of information. Like small things are also elaborated in great depth. So that's of course useful when you work on a problem and you're encountering some issues and you want to zoom into where the issue is. But for a first course, maybe it's you can read it like a storybook in some sense. Okay, and so I mean, for some of the topics, I will explicitly point you to some sections. So that's about this textbook. And for the prerequisites like probability and data structures, these are the textbooks. So Sheldon Ross and Bertzickers and Sitziklis, those are like really good books. So you've all done a course on probability, I know, and so this is just, it will help you to revise. So I guess these are the same books that you must have followed, right, for your probability course, right? Which books did you follow that time? Do you remember?
Both of them, ma'am.
Both these.
Sheldon Ross
And Sitziklis. Okay, good. All right. And for algorithms, this is the standard book, Codman, Lasers, and Rivest-Stein. So this, you can use this to brush up the topics. Okay, so this is about the theory resources. Now for the lab, again, the CS 188, they have a really nice framework which I really liked. Okay, so there are a set of projects which are already mentioned, and it's going to be based on this game that you see, this Pacman projects. Okay, so some part of it is going to be based on these Pacman projects. So much of the lab, work would be based on the CS 188 labs. Okay, so I would urge you to start going through this lab. So I will share this entire page, this page about the course itself with you, so you can get the links from there. Okay, so so these projects are, the thing I found was exciting about it is, you see, I mean, they have some framework which is already there. So like these games, right? I mean, they have a UI, and you can see your algorithms. So you have to code in some of the algorithms that you learned from this course. But once you do that, you will be able to see it in action. Okay, so in that sense, it's a very exciting framework. Okay, so I thought you will also benefit from doing these questions on these Berkeley projects. Okay, and another thing is, if you once you see it, you will know that there is some code which is already there, like there's some supporting code. Okay, so another good thing of having this is, at some point, once you move out from here, maybe you'll be in an industry, or we never know where everyone lands up. But if you are in an industry, the software industry, this is the kind of things that you do. Like there'll be some product, there'll be some code which is already there. You will go in and you will add your enhancements. Okay, you will develop on top of some existing code. Most of it's very rarely the case that you build something from like scratch. Okay, so of course, if you're doing a startup, you would do that. But if you are going to join some company, this is the kind of work that will go on. So you will have to understand the existing code, and you'll have to follow some kind of coding practices to ensure that you don't disturb the rest of the code. Okay, so this kind of framework, the Pacman projects, or what I call as the Berkeley projects, that gives you this kind of a practice. Okay, so in that sense, it's useful. And also another thing that I thought would be useful from this is that once you're going to do, suppose you're going to build your own startups also, I mean, you can use these as some kind of a reference to see how you build very large code. It's very modularized code, and so in that sense, you get some more info. It's a great learning experience that I will guarantee for you. Okay, so this is going to be our our reference for the labs. Okay, so I will, soon after this class, I'm going to release the first, or assignment 0 that I call. So that is primarily based on setting up your Python environment, and it's actually a very simple assignment. It's mainly to just get you started. It's kind of like a warm up. And so that's about the lab. And then in terms of grading, so the two components, right? Theory and the lab part. So the theory is going to carry 70% weightage and the lab is going to carry about 30% weightage. Okay, and in the theory part, you're going to have some theory assignments, a midterm, a final, and also there's going to be marks for class participation. I want you all to be like really interactive. Okay, stop me whenever you have doubts or anything you want to, convey something. Uh, Please be very interactive in class. That's how we can get the most of, such online classes, especially because I'm not able to see your faces, so I don't get a sense of whether things are clear or not. So you have to take the initiative, and that's exactly why we have a class participation. Okay, and here all the assignments are mandatory. There's not going to be choice. So I expect typically there's going to be at least 3 assignments and not more than 5 assignments. So it's anywhere between 3 to 5 depending on how much time we have, and all assignments are going to be compulsory. And these theory assignments have to be done individually. Okay, you can discuss among your friends. You definitely should discuss because that's a part of your learning. Okay, but whatever you submit has to be written on your own. Okay, or it can be written or typed. I mean, I'm not particular about whether it has to be typed itself. It's fine to even write it and submit. Okay, but the important thing is you have to, do it based on your own understanding. Okay. And for the lab part, so as I said, you're going to work on these Berkeley projects. And for the lab, you can work in groups of 2. Okay, because there is some effort involved in terms of, figuring out how the framework works and all that. So you can work in groups of 2. And if later you're finding it a bit hard and you feel that you need more people, we can increase the group size. That's okay, but let's begin with groups of 2. Okay, and so the programming assignment 0, which is going to be released immediately after this class, that one you can do it. You need to do it individually because it's not too involved. It's about setting up your environment. Okay, and just getting started. So that that you guys need to do it on your own. Okay, and for the subsequent assignment, since it's going to be in groups of 2, start thinking about the groups, how you want to form the groups. Probably like end of this week, maybe Akanksha will circulate some kind of a form or a sheet, to collect the group members. So end of this week or early next week. Okay, so use this time to figure out. Okay, and so for the remaining programming assignments, even though it's groups of 2, what I would encourage you to do is first, each of you, though it's groups of 2, individually try to think of the questions on your own. Okay, and then you can come together and discuss ideas and discuss the framework. So that way, like you are also, you feel that you have done your best. Okay, so that's one advice for lab part. And another thing is, these are Berkeley projects and there is a code of conduct to be followed. So you are not supposed to release the solutions. Whatever solutions you write, you're not supposed to release it on the web or even with your classmates. Okay, so please ensure that this is strictly followed. Okay, because at Berkeley now they know that at IIT Goa we are using their framework. Okay, so if you release it, it's not nice, right? If you see their files, they've explicitly mentioned that you're not supposed to release the solutions or anything. You're not supposed to give hints because it hampers learning of other people, others who are trying to work on this. Okay, so yeah, so this is about the grading policies. And yeah, for the midterm and finals, there's no collaboration. It's strictly a no. And you approach me if you have any questions. Okay, so all the lectures will be on Google Meet, and I think the link is shared on Classroom. I've also just mentioned it here, like on the screen. Yeah, the Meet link is here, and also the timings are there. Okay, so are there any questions? Maybe I'll just pause for a while, and if there are any questions from your end on the logistics of the course, you can ask now.
Ma'am, in the theory part, the percentages was written 70%, but
Yes.
the individual percentages don't match up to, like, don't add up to 70%.
Right. So this is the individual percentages. These are adding up to 100. So whatever you get out of 100 for this part, that then you further take 70% of that. So that's how I'm going to uh, keep the weightages. Okay, for
Okay,
both.
ma'am.
Okay, yeah, good. So, any other questions? Okay, so I presume there are no other questions. But feel free to ask me later also. Okay, so all right. So now what we will do is we'll just get started into the content of the course. Okay. So I'm just going to be looking onto a slightly bigger screen here. So yeah, I'm looking at you only, but it's on a different monitor. Okay. So I'm just not looking at the camera. Okay, so yeah, so let's begin. And I think it's now an era of AI, and there's so many applications out there. So I'm sure you all must have also seen some of the applications. Can somebody tell me, you know, what are the things that excite you when you think of AI? So it's not a time like, many years back, I would have to give you some examples and tell you what is AI, what are the things you can do and all that. But this is now a time when it has advanced a lot. So I'm sure you guys have already seen applications in somewhere or the other. So yeah, why don't you guys start telling me like what are the things that you know of AI and what excites you?
Ma'am, before that, can I ask a question? Like,
Yes,
what is
Anuja?
the exact difference between the machine learning and artificial intelligence?
Yeah. So good. I This was actually something that I wanted to also cover. So yeah, so you can think of AI as some kind of a broad subject in which machine learning is one part of it. So AI deals with several things like agents, robotics. There are a lot of such things which come under AI. Okay, and not everything deals with machine learning. So in machine learning, the thing is like you see some training data or something of that, and you have to learn something from the data, right? You have to automatically infer something from some data that you see. Okay, but in AI, so of course machine learning is a part of AI, but there are some more things in AI. Okay, so yeah, that's what you will also, I will especially focus on those aspects when it comes in the course. Okay, so that's a good question. So Tanuja, is it
Yes,
answered?
ma'am. Yes, ma'am.
Yeah. So yeah. So tell me some of the applications that you think. It's fine if it doesn't come under AI. Also, it's okay. But self-driving cars, right? So self-driving cars, autopilot cars, right? Yes. So
Recommendation system of
recommend
YouTube or Instagram, anything.
right. So recommender systems. All these are applications. Anything more? So GPT-3. So Sejal, what is that? Can you tell what that is? Conversational AI chatbots. Okay, wow, so many such applications coming in. So Sejal, can you tell
Yes,
us what
that
is
is
GPT?
like a language model that generates human-like text. So I once saw a YouTube video about what all it can do, and it was pretty interesting. So, for example, I like to eat blank. So it's trained to fill in those kind of blanks that way, language generation.
Okay, okay. So it's a way in which you automatically generate text, some meaningful language, right? Meaningful sentences.
Yes.
Right. Good. So, yes. So these are some applications. So it all comes under the broad framework of natural language processing, which in turn comes in AI. Right. And so somebody has mentioned, Himanshu has mentioned about NLP and robots, then advertisements. Yes. So what ads should you show to users, right? So all these are some things. So Tesla bot, yes, GitHub Copilot, right? Uh, Predictive search technique in Google Voice Assistant, predictor. Okay, right. So all of you have a fairly good idea about some of the things, right? So let me just. So of course these are all varied applications, and today there is no limit to what you can do, right? And let me just show you some kind of videos or demos which I thought maybe like it would excite. So first thing I want to show is this. Maybe you've already seen this, but this is a video in which there's this robot which is folding clothes. Okay, so this is a kind of system where robotics is helping like these kind of domestic chores, right? And this is kind of an old video, maybe something in 2011, and this is something that I saw when I did my first machine learning course. Okay, and this was exciting at that point of time. So this was maybe about 2011, 12, that time. And when I saw this video, I thought, okay, so this is nice. It's very nice. It's just going to be in some lab. It's an outcome of a research experiment. It's going to be in some lab. When is it going to come to mankind? Like when is it? When is it that you or I can start using this kind of a robot for our domestic activities, right? Because these kind of things, it's very useful, right? Like for for people who are working, it's these kind of things just come in the way. I mean, this is not something that at least I don't enjoy folding clothes. I don't enjoy a lot of domestic activities like this, and I'm sure that's the case with many of you. Okay, so this is a very useful thing, but at that point we were wondering, like, when is it going to really come into existence so that people can use? So that's what I thought then. But now in this year, like 2021, and in the last 3-4 years, some things like this have actually come into existence. For example, this is a vacuum cleaner, right? And this is a vacuum cleaner demo. So I don't know if the sound is audible. I don't want you to hear the sound anyway, but yeah. So this is a vacuum cleaner, that black thing that is being shown. So something drops over here, and the vacuum, so this is the kind of dirt that is there, and the vacuum cleaner automatically comes running, and it comes and in a second it's wiped up everything. Okay, so so these kind of vacuum cleaners are actually, it turns out that it's there in existence even now. Okay, I think I reduced the volume of the system itself, so I don't know if anybody said anything, but anyway, so these vacuum cleaners now, it turns out that they are actually there, and they have been produced and people can purchase it. Okay, and in fact it also showed up in some movie, I think I don't know if it was a recent Hindi movie, but maybe not too old. I forget the name of the movie. So there's this guy who was always at home, and so for his tasks, they showed this vacuum cleaner all the time, this robotic vacuum cleaner. Does anybody know the name of the movie? Okay, was this something that only I saw this movie, and it's, okay, anyway, I think it was on Netflix or something, it was there. So, but anyway, the point I'm trying to make is, these kind of things are now very much part of our lives. Of course, it's not that you find robotic vacuum cleaners in every home, but it's now available in the market to purchase, if, so it's, of course, there are a lot of issues and it still needs to be developed. It still needs more features and accuracy, but the thing is, we're not far from a time when all these, these fancy products, what was fancy at one point of time is now actually in the process of, coming to mankind. Okay. And so one more thing I wanted to show you was, okay, I'm just going to show you a picture. So do you know where this, can somebody tell me, like, I don't know if you've been to this place. Any guesses on this place? I'm just trying to see if you can how good is your classifier, your built-in classifier, but or your object recognition strategies. Any guesses on where this place is? Anybody? Anyone can answer? Just unmute yourself, guess something. Okay, am I audible? Are you all able to hear me?
Yes,
Okay.
Yes, ma'am. Yes, ma'am.
Okay, good. So, yeah, so why don't you make a guess on where this could be? Some kind of a hill, right?
Kurd Ladakh.
Ladakh? Yeah, it looks very much like Ladakh, right? But yeah, it's not Ladakh. Good try, good attempt. Anybody else? Say something, any place. What does it, yeah, maybe you haven't been there, but anything it reminds you of? It's a mountain range.
Rajasthan.
Rajasthan. Okay, good attempt again. But unfortunately, no. Okay, it's not in India, that I can tell you for sure. Okay, fine. So some of you have made guesses, and yeah, this is what when I first saw it. So let me just tell you what this is. So this is actually Mars. It's an image of Mars. So okay, so yeah, it's fine. I don't expect any of you to have. Definitely, I don't expect you to have been there. Okay, and so this is an image taken from the Curiosity rover from NASA, which traveled all the way to Mars. Okay, and it's still there, and it's taking images, it's doing experiments, collecting data. So this is an example of a system where AI has been like really useful. It's a very sophisticated system where AI finds existence. Okay, so from all the way, like you cannot hard code these things, right? You're sending something to a different planet. Now the time it takes to send something, some communication signal from the Earth to Mars, that's anywhere between 5 to 20 minutes. Okay, so it can take as long as 20 minutes. So right from the point where it has to step down on the ground and walk around, it needs to be in a position that the device has to be in a position that it can do it on its own. So it should be able to learn on its own and do all these tasks with minimal external guidance. Of course, you can send some updates at some points of time, and I guess that's somebody's monitoring to do those kind of things. But every instruction cannot be given to it from the Earth. Okay, so so you see that this is a great activity that AI is really contributing to. Okay, and so you see that this example was just to say that there are a whole spectrum of applications, right from domestic chores, which everybody identifies with and finds a lot of use, to something like this, a mission in space, right? And which, of course, there is a lot of use for mankind from this kind of thing, like where you do some research on what is the thing on Mars. Okay, but this is the kind of range and the potential for artificial intelligence, and there's a lot to be done in this space, and I think this is an exciting time to be in AI. Okay, now about again, going back to Tanuja's question about what's the difference between AI and ML. Now, if you think in terms of this, this rover which went to Mars, there's one part of it which has to figure out how to go around in Mars, how to direct itself, how to navigate through the place. And then there's also one part which needs, it needs to identify or see something and identify that it's worth taking a picture. What is the thing? Okay, so here there are various aspects. Or even if you look at the vacuum cleaner example, Now, there is a part when the vacuum cleaner has to just go find its way through a home or wherever it is, and there is one part where it has to identify that something is dirt. Okay, so not everything on the floor is dirt, right? Sometimes, I mean, you might have important things on the floor. Okay, I mean, if you're not very spick and span, maybe there's some things on the floor which is not dirt. Okay, so so here there is a part which comes, which is ML, which machine learning, which says this is dirt, this is not dirt, and this is something which it has to learn. And then there is also a part which it has to navigate itself. So this navigation part is not really part of machine learning, but this all this comes under artificial intelligence. Okay, now having seen some applications, I also want to draw you back to these Berkeley projects and in terms of game development. Okay, so a lot of things in AI are developed using games. Okay, so why is it so important, right? I mean, of course, games are something which is entertainment. All of us like playing it, but why is there so much of focus on games in AI? So we have things like chess, and now in this course you're going to be doing something on Pacman, right? So what happens, like why is this the case? So it turns out that a lot of issues that you have in these robotics or these real systems which are doing some tasks have some similarity with games. Okay, so to see that, let me just show you this Pacman game, which will be an integral part of your semester. Okay, so let me just start the game. Just do this demo. Is the screen visible? The game box?
Yes, ma'am.
Okay. So how many of you have played Pacman? Can you give me a sense of whether you've played, whether you're familiar with it, you're not familiar with it? You can type or you can say played it. Yes. Played it. Yes. 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 Okay. Good. Okay, so I see that a lot of you have played it. That's great. Is there anybody who has not played it? I mean, I would like to, maybe if there's somebody who's not played it, maybe I'll just explain a bit of the game and what it's supposed to do. Right? Okay, so nobody's saying, but I don't know if somebody's shy to respond and not saying. There's nothing wrong, okay, not knowing about this game. It's absolutely fine, okay? So let me just anyway tell you briefly about what it is. So, so you see that, this yellow one, this one here, this is me. This is, or if you are playing it, this is you. You are this agent. And there are these other guys here. Those are the ghosts. Okay, so maybe I should just make it a bit slow. So, yeah, so this yellow guy is it's your actions. Whatever you do here is, if you move on your keys, this will turn, the yellow one will move, okay? And these two are ghosts. And these white dots are what you should eat, okay? So these are called food. And that's what Pacman has to eat. So this yellow thing is called Pacman. And these huge particles. You see, there are some particles which are small and some which are slightly large. Okay, so large ones are called capsules. Okay, and so if you eat the capsule, you get some more points. So you can see that each food particle I eat, the points increase. But if I eat the big one, the points increase quite a lot. And when you eat those big capsules, these ghosts become, they also become food. So ideally, you should be avoiding the ghosts. But when in this state, like when you have eaten a capsule, if you go near this, if you go here, you will get additional points. Okay, if you eat a ghost, so you can eat a ghost now. Okay, so let me try. I hope it doesn't change. Okay, so that has happened, and now this has transformed back to ghost. Okay, so you've got some more points, and this became a ghost back to normal. And see, so this is not a permanent state. So the ghost becomes food for some point of time, and after that it goes back to a ghost state. So the idea is to be able to eat all the food particles without being caught by the ghosts, and also you have to make a good score. Okay, so now when I play this on, this is now I am controlling it. I am not very good at this game, to be honest. Okay, see, I've died now. Okay, so there are all these issues like, okay, so how comfortable am I with the keys, and how much practice do I have with this game? This clearly shows that I don't have practice. I had to reduce the speed to much slower. Okay, so this is a game, and how do you make how do you build an automatic Pacman? So in the sense, how do you build an agent which plays Pacman? How do you make the machine play automatically against these ghosts? Okay, so if you look at this game, there are a lot of subtasks, right? So here you have to learn to go around. So this is not just a straight path. You have to be able to navigate yourself. So there are these walls here. You have to be able to go around, and you have to be able to sense where there is food and see. Be able to direct yourself to the food, and you should be able to cover all the food particles. And you should also avoid the ghosts. So there are a lot of things here. You don't know how the ghosts behave, and there's so many sub problems here. Okay, so in terms of when I see this, I see the analogies with the vacuum cleaner problem, right? So these food particles are like the dirt pieces that the vacuum cleaner has to clean, and the path is not a straight path. It has to go around, and there'll be walls in many places, and Pacman has to navigate itself properly. So, and there are these ghosts. So maybe those are like humans. The vacuum cleaner shouldn't really collide with humans. Okay, and so these are some of the things. So there are a lot of analogies between the game and the real products that you build. Okay, so in this course, what you will slowly learn to do is you will build a system like this, which you'll build a system for automatically learning. So what I will just show you now is some intermediate stages. So I have written some code based on your labs, and you will also be building something like that. So let me just show you some intermediate stages of what the code you write will be like. So first let's look at this case where there are no ghosts. Okay, so you only have have this task of going from one place to the other. Okay, so let me just run this to. Okay, so what I'm going to do now is there's just going to be one food particle, and there are no ghosts. So from Pacman's current position, it has to go and find that food particle. Okay, so I'm just running this. This is you will know this. You will know how to run this later. As you build on the labs. Let's see this. So it started here. Pacman started here, and the food is here. And this is a kind of maze. And I've written the algorithm so that it can figure out its way. Okay, and this is not hard coded for this layout. For instance, this is what was called a medium maze layout. Now I will run a big maze layout as well. So you see, this is a more complicated maze. So the Pacman started in this right corner, bottom right, and there was no direct way to come here. So it had to figure out a way through all these, these curvy paths, these amidst these walls. And yeah, looks like Pacman is on its way, right? Because there's no way to just jump. It had to go through this path, and it's reached. Okay, so this is something that you will also build. Okay, so this is kind of the initial stages. After the first few classes, you will be able to build something like this. And so this is for one dot. Now, what about, if you have many dots, what do you do there? Okay, so that also I will just show you. Just give me a second. So okay, so this is a more complicated thing with a lot of dots, but how does Pacman do? Right, so it looks like it's there's some strategy which has been built in, and it's able to, just very easily gobble up all the dots, right? Just look at the way it's doing. It's doing it very fast, right? It's not battling an eyelid, and right. So these are some things. These are you can think of these as some intermediate stages, and this will be a part of your Pacman projects, the Berkeley projects. And see, there was one last one there, which it came running from somewhere and found it. Right. So these are some nice things, and this was a stage where it just. It was known to the Pacman, what is the reward? If it goes into, if it eats one food particle, is it good for it? All this was told to it. But ultimately, in a real system, it has to infer things on its own. So that's where some things like reinforcement learning will also come into picture, and you will also be doing that. So let me just show you let me just wind up with one last demo. So that's the reinforcement learning demo. Okay, so let me just tell you what this does. So this is going to do some training for some 50 games. Okay, so this 50 is for that. And the last game is where, it is not a training. It's going to actually do what it learned from these 50 games. Okay, so now you can see that it's beginning some 50 episodes of training. It's trying to learn by looking at its environment. So now you see, I'm not doing anything. I don't have any controls. It's learning to do this on its own. And you see, it's so bold, right? It's just going near the ghost. I wouldn't do something like that if I was going to play this game. But it's able to do this and also win the game, right? So, so this is some exciting thing about how you gradually build the product, and you are also going to do this. So I hope you're all excited about this course. Okay, and I think if there are any questions, I can take it now. Otherwise, we are going to, very soon after this class, you will get the first lab assignment. Okay, and this is to be done individually. And of course, we will be meeting on Thursday for the lab part also to clarify doubts and everything. But we'll start going through the lab exercise, and the deadline for that is just a week, because it's just a warm up. So the deadline for the first lab assignment will be on the coming Monday. So today is Tuesday. You have time till next Monday. Okay, and we will meet again tomorrow. So today's Tuesday. So Wednesday at 11:30 will be the next class. So we will stop here, and if there are any questions, I will just hang back. Otherwise, thanks everyone.